Hello, everyone. Welcome to today's Tuesday topic. Today's topic is data management and sharing. Is your data repository ready? While we're waiting for a few more folks to join us, I see some more folks coming in from the waiting room. Let me just introduce Renee Moore, the Director of Biostatistics and Scientific Collaboration Center, and Daniel Vader, the statistician from the Biostatistics Scientific Collaboration Center, who are going to present our second in the series on data management. The next one will be up in the spring, so we're not ready for that one yet. Also joining us online is Dr. Trish Savokis. Hi, Trish, sorry. We're ready to get going in just a second. All right, thanks for joining us. Dan, take it away.
All right. Do you want to start us off, Renee?
Sure. Hi, everyone. Thanks for joining us. Darren, thanks for that introduction. So this is part 2, and we know some of you may have been there and some of you have not. So for those of you who are there, get ready for a quiz. We are going to review last time because it feeds into this time, and then we're going to get into today's topic. Are your data repository ready? Okay, so last time we talked about data management. And so what is data management and security? Describes how you collect, store, secure, access, and disseminate data. And that we want to demonstrate respect for our participants, we save time, we improve scientific rigor, right? Always rigor and reproducibility, those scientific process. So our questions are that we talked about last time. What is data management and security? How do we support data management? How can your team practice good data security? And what resources do we have here at Drexel? And then we'll go into a couple scenarios to say what's wrong. Okay, so first one, how do we support data management? Last time we discussed at least 4 different ways. Even if you weren't here, if you can just indulge me, type in the chat, come off mic, those in the room. How do we support data management? What are some important aspects? I think I lost one person when I asked the question. Dan, you want to help us and chime in with one?
Yeah, well, one I can think of that's very important is administrative security. So that's basically just making sure that you have someone who knows what you're supposed to do and kind of knows all of the rules and how to communicate those rules to people, and just generally kind of have the structures in place to make sure that data doesn't go where it shouldn't go.
Okay, so those of you with teams out there, those of you on teams, who's your administrative person? I'll tell you, for my team, it's Dan. He knows those details, not me. All right, so
accessibility.
Accessibility we have in the room. Yes, accessibility. Okay, so the 4 things we talked about was policy and protocols. File naming and organization, documentation, personnel, technology, and tools. So all of these are good components of our best practices for data management. Then we talked about 3 principles of data security, and Dan touched on one, administrative and organizational data security. Anyone else have another one? De-identifying data, that's part of our data security.
Yeah, and de-identifying data is sort of a kind of administrative and digital security, because it both helps you control who has access to what data, and also kind of makes sure that like certain data are more digitally available than other data. So that one kind of fits into like a bunch of the different boxes.
All right, I'm writing to you all online. And so we organize the 3 principles of data security as administrative or organizational, physical, and digital. And so, so those are 3 principles of data security. So feel free to chime in with questions or chime in the chat. Review. Okay, next slide. So another thing we talked about are Drexel University tools. And so what is the most secure data storage tool available at Drexel? Or even where are you storing your data? It will be. Where are you storing your data, Martha?
I think the slide, it's already on the slide.
Oh, no, we didn't do animation. I think when we switched it over.
Oh, the animation did.
Yeah, the animation didn't come in. Okay, I have a OneDrive.
Yeah, OneDrive's a good one.
OneDrive's a good one. Martha said it's on my slide already. That's the Drexel encrypted network drive is the most secure one we have here at Drexel. And then I think if you hit the next one, we also have what Rachel just shared with us. Hey, Rachel, Microsoft SharePoint and OneDrive. So those are some of the data storage tools we talked about. And last time we gave pros and cons. And if anyone wasn't with us, check out the CNHP Research YouTube channel where we went in more details. I looked at Darren for those not in the room. All right. Data sharing. What are the 2 Drexel tools for securely sharing data?
Well, Rachel pointed out one already.
Okay.
That's OneDrive.
OneDrive.
So if you're sharing within your own team, you can share data on OneDrive and manage access on OneDrive. There's another one that's even
Liquid files.
Liquid
Liquid files is another one that you can use you can use both with internal and external collaborators. And it's got some cool features that let you kind of keep track who's downloading your data and things like that, which is really helpful.
All right. So we know how to do data security. We know how to data share. Let's go into an example scenario that may or may not be based on something that's happened to us. Go ahead, Dan.
Or might be generalized from a lot of experiences that we've had with different teams and people and organizations. Okay, so here's the first one. Your group uses Microsoft Teams to share documents, good, and store data related to research you are conducting on mental health diagnosis and treatment among adolescents recruited across several local clinics. After some time, you find yourself overwhelmed with communication and organizational work and decide to hire a project manager. You find someone and they start immediately. You give them access to your Microsoft Teams project so they can get familiar with your study protocol and clinical partners. It will take at least 2 weeks to order a Drexel managed computer, but you assure them that they can use their personal laptop in the meantime. So there's a number of things going on here. What did you do wrong, or what did the investigator do wrong in this scenario? What could they do differently? And how might a data management plan have helped? And there's multiple right answers here, so feel free to think creatively.
I can't see the chat. So, all right. Any red flags raised in that?
Sorry, could you treated the person as an external partner and use like liquid files to share data with them?
Yeah, so I probably wouldn't share data with them right away, just because they are, you don't want them to have anything on their computer that they're not supposed to have. And liquid files, you're still sending a file to them, just the process of transferring it over is secure. So that's a good point. I think one of the things here that this gets to is that that you kind of get at with that is that when you give someone access to your whole Microsoft Teams, that gives them access to kind of everything in your project, unless you've got things deliberately separated out. Yeah, and Rachel says that it sounds like a lack of onboarding process, which is 100% correct. I think that's probably the biggest problem here, is that this new person wasn't kind of taught what they should do, and the person who was kind of onboarding them also didn't know what they should do in this situation. So I think one good thing that someone could do would be to kind of separate out the documents that this person needs access to get onboarded and the documents that they can't have access to until they're onboarded.
And when I raised red flag, I heard something else coming out. What was the red flag? You were about to say something.
Oh, that it's a personal laptop.
A personal laptop.
Yeah, 100%. Yeah.
Yeah.
Yeah, so none of your work should be on a personal laptop. So the laptops that Drexel gives you are they're encrypted and managed by IT here, and you shouldn't have any kind of extra programs or stuff that you would use in your personal life. So they're much more secure than a personal laptop would be. So I think it's okay to use a personal laptop to look at things that are shouldn't be like secured, right? Like, so if you're just like, I don't know, if you're just reading a document that's like available to the public on your personal laptop, I think that's okay. But if you're dealing with sensitive information, then you should never be doing that on your personal laptop.
I think your general IT would say no personal laptop, because sometimes that line, we don't know about it. And
Right.
So similar to Rachel talked about onboarding protocols, also as a team, we have to plan for new team members coming on board. And we hope that we can order their equipment ahead of time. If we can't, we hope that there's some loaners, Drexel loaners around that we can use.
Yeah, and it's good to talk to your IT person about this too, because it's something that can be very difficult. Last job I was at, it took them several months to get me my work laptop, so we had to figure out an alternative solution. So yeah, talking to IT is your friend.
So it seems to be the case where if you could at least get set up on something in terms of a OneDrive, so there could be a minimum level of security, even if it is a loaner and so forth, until you could really be able to have a secure environment to be able to do your work.
Yeah, so I would be cautious even with putting a OneDrive on a personal computer. If there's sensitive information in that OneDrive, because it works sort of like if you've got Google Drive or anything else like that, then people can pull files from that directly on their computer, or you can set it up to automatically sync with your computer. This is a problem we had at my previous job with one of our projects, where a bunch of data was put on a cloud storage thing, which was HIPAA compliant. But that cloud storage was synced with a lot of individual investigators' computers. And so that meant that all of that data was then on all of these computers in these different locations, which ended up being okay for that project because it was de-identified data. But it still wasn't good data management practice. So yes, OneDrive is a good place to keep stuff, but you need to be very careful when you're.
Well, my intent wasn't about a OneDrive being on a personal computer. It was on a loaner. And so to have some type of loaner situation set up, that would be probably a minimum level in terms of accessibility.
Thank you.
But thanks for that example. That's one of the issues.
Think with loaners, I think IT, when you get the computer back, they might erase everything that was on.
Yeah. So loaners, that's an excellent example, Trish, and a good point.
Yeah.
That loaners, IT will take care of them afterwards to make sure no data goes somewhere it shouldn't.
All right.
Okay. So second one, you're studying end-of-life treatment and care among individuals with cancer using electronic health record data from a large health organization. The data are very messy, but you're able to hire an ambitious graduate student to clean it and run your analyses. Everything goes smoothly, and you present a poster and your results and submit a manuscript. So afterwards, you decide to run a follow-up project, but need to hire a new student since the old one has graduated and moved on. The new student cannot make heads or tails of the data set created with the original project and ends up starting the whole process from scratch. In the meantime, reviewers like your manuscript, but would like some minor clarification on how certain variables were defined. However, you cannot find the original documentation, and your old graduate student is not responding to emails. So again, what sort of went wrong here? And there's a lot of things that potentially went wrong. And what could the investigator have done differently to prevent these things from going wrong?
Didn't have a data dictionary.
Didn't have a data dictionary. Yep. That would have helped a lot.
Graduate student left, the PI should have met with them and made sure that they had access and understood the work that they did.
Mm-hmm.
And maybe the graduate student wasn't appropriately supervised either, because that shouldn't have happened. Somebody leaves.
Yeah, and you're very quick to identify all of these, which makes me feel like maybe you've experienced or heard other people experiencing this.
A lot of things.
I have definitely experienced this personally too.
Rich has a comment?
Yeah, sorry. Chris.
Yes. So the importance of documentation and organization, as well as within the organization, storage and backups, the whole nine yards. All of the sets a nice entree in terms of how critical data management is, and for being able to reproduce the results, and then also the process, as Renee intimated and Dan did too. So
yeah, absolutely. So everything, and we talked a bit about this last time, and sort of organizing, right? And in our OneDrive, and for each project, who has folders, but in this folder, I would like to say that in every folder of individual in a project, right, we're going to have a folder with data, and there's always a raw data in there that's untouched, how you received it. And then there's derived data, and then a final data set or final analytic data sets. And then we have, as Trish is saying, right, our programs and things and documentation. If you're programming from scratch, like in SAS, it should be well commented notes for every procedure you're doing. We like to do too on README files of things that might have to be replicated or extended. Perhaps you're on a study where it's long-term, and when the next time point of data comes in, we can have README files that go through how you go through the program and how now we read this data, clean it in, bring it in. We also usually have a documentation resources file as well, and then a result. So again, thinking about what are the different folders that you want that make sense for your team, and we can provide examples of that. But I definitely have been burned from this one. I'm a little too trusting and optimistic, and kind of trusted that they put it all in there the way we talked about, and then I'm like, oh no. So I appreciate Dan, last week on a Zoom with one of our students working with us, Dan said, and you put all of this on our folder, right? And he said, yes. So definitely don't be naively optimistic like me. Check in and make sure everything's going where we discussed. All right. And then we had one more from last week. I guess next slide. Sorry. Last time we received a question after our presentation, so thanks. Good to know folks are still thinking about this. And the question was, what are major pitfalls for the first-time users and developers of a data repository for research? So in those two examples, we just talked about some of these things, but major pitfalls we identified: not having an administrative plan for data security, not building strong data documentation from the start. And so again, just elaborating on what we just said, it's easy. I've also been burned by, at the end, we decide to do all this documentation, or at the end, right, they're like, oh yeah, I need a data dictionary, a code book, right? It's a lot harder if we're doing it at the end or in the middle.
It's like archaeology at that point.
Yeah, it's archaeology. And I know many of you are like all of us, we're juggling too many things to do well in that archaeology exercise. So from the start, we talked about this as well, not training your personnel on administration, management, and security of data. If your personnel don't know what to do, how can they do it? And also we want to put in there, we don't have to reinvent the wheel to become aware of resources that are out there. NIH materials, we shared some of those. And then also our colleagues, consult with experienced colleagues or others who have had this. Anybody else have any other thoughts out there for major pitfalls for first-time users and developers?
Well, it seems like the adage, pay now or pay later, comes to play. And it's better to pay up front. You're making an investment not only in science and the resources that you're using, but also you're saving a lot in terms of time down the road, the recreation. So pay now or pay later. I'd say pay up front. It works out better for everyone in the end.
Absolutely. Thanks, Drew. pay up front now, right? The time as well as the stress, the mental stress of all this, having to go back and having to worry about this and having to report to NIH and DSB, and all of a sudden we're scrambling now for the report. So yes, pay up front, as Trish says. All right. So that's what we wanted to review from last time. If you have any other questions, again, feel free to chime in. We're going to go into part 2, today's learning objectives. Is your data repository ready? And in getting ready, we're going to talk about the FAIR principles of data management. We're going to talk about data code books, and then look at some of NIH's data management proposal templates. And again, just review.
Yeah, okay. So we're going to start out by looking at the FAIR principles of data management. And these principles, and we'll go ahead and define them in a second, are what the kind of new NIH data management policy is sort of based around. And so understanding these can kind of help you understand what the new data management policy is kind of getting at with their new requirements. Does anyone know, like off the cuff, like what FAIR actually stands for? And I've looked at this a number of times and I keep forgetting. So this is honestly an easy thing to forget, but if you know it, then it's great.
Anyone know what the acronym, the letters in FAIR stand for?
Or even one of them, one of the letters. Well, I know that, sorry, go ahead.
It's just thinking in terms of all of the points that we've made. It's nice to have an acronym. And so one of the things we're trying to do is to find the data. So the findability of the data is F. Accessibility, as we continue, is next. And then I'm trying to recall the other the other
That's
two.
good, Trish. You're doing better than me for 2 out of 4.
You jogged my memory. So the I think is interoperable.
Yeah.
The R is reusable.
Yeah.
So those are the four things that these FAIR principles are kind of concerned with. And they've got this little diagram for how they think that you should go about approaching FAIR principles. And there's a whole website like specifically about this way of thinking you can go through. It's got some gofair.org has kind of walks you through all these different things, which is really nice. And a lot of the resources we're talking about here are from that website.
They call it the verification process.
Yeah, the verification process.
They made it a noun as well.
Okay, so again, like just kind of think about tying these to those new NIH rules for making a data management plan. So the first one here, as we discussed, is Findable. To quote from the website, the first step in using or reusing data is to be able to find them. And metadata is basically data that's about data. So like things that describe what are in data and like tags that help you find things. So like if you're Google searching something, chances are that if you're able to find it, it's because someone put in some good metadata about their webpage there. They should be easy to find for both humans and computers. And machine readable metadata are essential for automatic discovery of data sets and services. So basically, you want to make sure that people can, like once you publish a paper or publish an abstract or present a poster, people can actually find your stuff. They can find where everything came from. And this goes both for external collaborators and for internal collaborators. So if you think back to that example that we talked about earlier, where we were trying to make sure that all of our information was in one place. That's partially because sometimes people go off and they're working by themselves, and then you don't know where anything is that you need to try and find. So that's even within a particular team. And if you go and extend that to published research, it becomes even more difficult because you'll find all these papers that are published online. You won't have any idea where to find the data that they used in that paper. And they might say like data are available upon request, but sometimes that means that they'll never get back to you when you email them. So I think that part of the intent of this NIH policy is to make sure that that doesn't happen, so that kind of science is better, more auditable, more kind of redoable than it is. So yeah, this is like a main concern.
And for our PIs out there, is it still for NIH studies 3 years after the end of your study that your data has to be publicly available? Or is it only some of them?
With the new policy,
Or even before the new policy?
I think only if
So is it only-
your data had to be publicly available before the new policy based on the funding level.
Oh,
So if you
okay.
were getting grants, I think over $500,000 a year, then
Then it
that's-
was,
yeah.
okay.
Mhm.
So I wonder if the new policy, if they change that
well, yeah, you have to have it available.
now for
Yeah.
everything.
Yes, for everything.
Okay, all right.
Yeah, I don't
Thank
think
you
I
for
saw
that.
any like stipulations with the new one saying that
Okay,
like only
alright.
these people do it.
See that? I'm still learning, so asking questions for everyone. So before it was
We're all
over,
learning.
yeah. So before it was over a certain level of funding,
I
your
believe-
data had to be available. But now under this new policy that went into effect, January 25th of this year, all data from NIH studies has to be publicly available. And is it still 3 years or do we know?
I
that?
think it's,
Yeah, go ahead. No,
I think it's within, by the end of the study, you have to have your data ready to share.
Okay.
yeah, and then I think it is 3 years after that.
Yeah.
I think, but I wouldn't like quote me on that.
Yeah, don't
But again, in the theme of Trish, right? Pay for it up front. I'm asking this because I really am not remembering the details, but also saying that, you know, this is a process we need to think about and provide funding for and time for upfront. That and that part of this, you know, the NIH new policies. But I have been, you know, before this policy and even before the 3 years, I remember the first time I had to do this and prepare the data set. It takes a lot of time. So pay up front, plan, and plan for that proactively. All right, that A, accessible.
Yeah, accessible. So once the user finds the required data, so they know where it is, they need to be able to actually access it. They can't just say like, I know where that is. It's fine. It lives there, but I'll never be able to use it. So NIH wants people to be there to be some kind of process where people can request access to data and then, if appropriate, get access to that data. And there are different systems in place to try and manage this. We're still working on trying to figure out the best way to what the best system is to do. And we'll talk about that a little bit more later, but yeah, another important step. Okay, interoperable, so the I. Data usually need to be integrated with other data. And in addition, the data need to interoperate with applications or workflows for analysis, storage, and processing. So basically what this means is you need to be intentional about kind of how you put your final data set together. You see when you work with like a lot of different people and projects, you see like all sorts of wild different types of ways that people decide to put their data together. And Renee was telling me about one the other day that sounded pretty messy. And what this means is that when people want to use your data again, either to kind of reevaluate your study or to conduct work on your own that builds on work that you've done, they need to be able to kind of like plug your data into their own system, and that data needs to work. So if you're doing something that's completely like of your invention, then sometimes things can be really difficult for people to kind of replicate anything that you've done. Yeah, so you basically want to make sure that your stuff's in a common file format, everything's named sensibly, everything is well organized. Again, it just comes down to this organization and intentionality to everything you do. And finally, we have reusable. So, and again, all of these things sort of work together. The ultimate goal of FAIR is to optimize the reuse of data. And to achieve this, metadata and data should be well described so that they can be replicated and or combined in different settings. So again, this kind of just summarizes everything else that we've had here, but you do want to put in key information about your data and have that data have that information about your data readily available to people who might be working with it, such as where did your data come from? You want to have data documentation that follows standards and vocabulary set by your field of research so that other people know exactly what you mean when you say something. So again, just more questions to consider as you're trying to be very intentional about planning how to put your data together for a project and how to share it later.
All right, let's switch into code books. Code books, data dictionaries, essential for reusable data and reproducible research. So when I say, what's a code book or what aspects should be in a code book?
Variable names,
Variable names, yes.
the labels, the definitions.
The labels, the definitions, absolutely. And so a definition, a code book describes the contents, structure, and layout of a data collection. A well-documented code book contains information intended to be complete and self-explanatory for each variable in a data file. So someone should be able to pick up your code book and they don't have to consult you to understand the variables, to understand the content structure and the layout. This should be a document that lives beyond you and your current team. All right, so instead of, we like to share through examples. So Dan's gonna share one with a current CNHP study.
Yeah, so this is a code book that we've prepared for Dr. Justine Sepchik and Martha Coates, who's actually here with us in person today. We've been working closely with them on a research project. And so I guess first, let's look at, this is a document that was amazing for me personally when I was putting together this data set for this project. And this is a document that Justine and Martha put together that described kind of all of the variables from, this is an NHATS-based study. And if you know NHATS, you know that it's a really big and complicated public data set that can be a little bit confusing sometimes. So Martha and Justine put this together, and
I saw that Roseanne's a contributor too. I just noticed that at the top.
not acknowledging fully everyone who's involved. But you see, one thing that I really like about this is they've got kind of what the variable is. They've got what it's actually called in the original data set, the label for it, and then kind of what the codes for it mean.
And in clarity, that's the NHATS variable name.
That's correct. So this is the original data set. So we have not done anything to it. We just pulled this off the NHATS archive. And these are the things that we would need to use to put together our variables. And one thing that's especially helpful about this, let's see if I can find a good example, is there are some of these variables which we call derived variables. So these are variables that are made up of, they take original variables, and then we're going to use those original variables to create a new variable. And what Justine and Martha have done here is they've put together the names of all of the variables that we need to create a derived variable, and then defined how we need to put all of those things together, complete with a reference even here, so that we know how to derive that variable. And this is just amazing. This means that A, all this is well documented, people know exactly what we've done, and B, when you're passing it along to another team member, like Justine and Martha passed it along to us, we know exactly what to do. We don't have to have lots of back and forth over email to try and figure out exactly what anyone means. It's all just there, which is incredible. And then we used this to create a analytic codebook. So this is basically the variable. We took all of that original data from NHATS and we created what we call an analytic data set. And this is the data set we're actually performing our analysis on. So that includes some recoding of some things, that includes creating those derived variables we talked about. And this describes kind of what each of those new variables are, what they're called in the new data set, and some notes on them. And personally, I would like this to have even more detail than is in it right now. But this is a good start. Yeah, does anyone, before I pass it on to Renee to show us another code book. Is there anything that you think that you would like to see in this code book for the analytic data set that you do not see here?
What more would you like in that code book?
So I would like more. So I would like a little bit more tying those two code books together. So this is kind of pretty separate from the other one. So it's hard to know how some of these things lead into one another. Some of these, in some of these, the variables have been collapsed. So this used to be more categories than it is now, and I try to be very specific in labeling these. But I should probably have in the notes that this was collapsed from this variable in the original data set. But yeah, like there's almost no such thing as too much detail as long as it's well organized and people can work their way through it.
I might have some of that in the next example.
Well, one thing before moving on, it's nice that you applied one of the best practices in terms of the identification of the variables having lowercase work.
Yes.
That allows it to be more transferable across a variety of programs, and it limits the errors that you might have in terms of bringing up your variable names. And as you contrast that with the original data set, the NHATS was brought down, which had an uppercase letter as the first point in terms of the variable name.
And can you just elaborate a little bit more, Trish, on why that is helpful?
Well, let's say that you are using this data set in one program, and it may be useful in terms of another program. So let's say you've worked with it in SAS, you've worked with it in SPSS, and now you're going to work with it in R or some open source program. And what happens is there are different conventions used across the different software packages. But if you have lowercase letters or numbers used in terms of your variable name, that allows you to say, okay, regardless of what program I'm using, it's going to be pretty much accessible through all of those programs. And so if there are particular components within a programming language saying, oh, well, your variable name can't be longer than this, you could make an adaptation more quickly or use a particular character to extend it to make it meaningful, but yet maintaining the integrity of whatever's going on in the program.
Yeah, thank you. So that directly plugs into the I in FAIR, the interoperability of your data. Okay, I'm going to click over to one of a different code book. Which one of these would you like me to pull up?
I think that one is good. And so, the Word document.
The Word.
Please. And so this is an example code book. Well, this is first the baseline list of questionnaires. So this is for a very large prospective observational study. We have in the PI is one of my collaborators at Emory University, Dr. Tanae Lewis. She is epidemiologist by way of a psychologist, has a large interdisciplinary team from master's students to PhDs to postdocs, junior faculty, Ford fellows. They are studying women's health, sociology, and so a large interdisciplinary team. 800 women enrolled in this study. We're moving on to the third year of data collection. And so we have a lot of investigators who come and they have an idea for an abstract, for a manuscript, and they need to know what variables are available. And there are literally thousands of variables. So first we start with the scales, or they call them constructs, or the questionnaires. And so in this 5-page document, we have, I think, all of the questionnaires. This is not the lab data. We also have sleep data, for those familiar with PISI, that comes from a sleep center. But this is the questionnaire data and the scales data. And as Dan is scrolling through, you'll see it's 5 pages long, a lot of different scales. People might not be familiar with the scale. So the second column is a topic. And then we have references for each of these scales, and that's at the end. So you can go back to the original documentation on how these scales and questionnaires were built. And then if you scroll back up for me, Dan, you'll see this, what is the fourth column is a SAS variable name, and scroll up for me a little bit.
Yeah, you want to see the header?
Or even, yeah, the header is good. Yes, the first page is good. All right, and maybe scroll a little down. But what you'll see if you scroll is a little down for me. There we go, stop. Okay, so the last two columns, sometimes they're filled in and sometimes they're not. And so the third column is SAS variable name. So as you see, these are 5 pages. We have not got through all of these questionnaires in terms of bringing them in and creating an analytic data set. So the third column is SAS variable name. And the fourth column is also, and the title is, it's created by the SAS data set and QC'd by, quality control checked. And so for this team, for all of our derived data sets, we also have a quality control. In particular, because as I mentioned, there are a lot of trainees who are not statisticians and they do want the experience, or part of their thesis or their dissertation, they have to code themselves. And so they code themselves, but then someone from the stat team QCs. And so if you scroll down a little more, I think you'll see examples, like you see names of who is the original code, and then there'll be a name added, and you see that third column of SAS variable names. So we give this out to our investigators, or those wanting the data, to say, these are the scales that we have, these are the topics, and also these are the ones for which we've started to create a derived variable set in QC. And now if we go to the Excel document, this is an example of one of the scales. It's actually one of my favorite. It's called the Superwoman schema. And so this is for one of the scales. I think if you scroll right, Dan, you can get to the beginning. You might want to, left, my bad, right, left on the computer. And the top, but what you'll see in here are the individual items for this scale. And so we have the question name, and then we have the original raw name. And actually these were collected in an instrument called Survey Gizmo, which I do not recommend. They started that before I came on board. That's another story to share. But the questionnaires were placed in a collection tool called Survey Gizmo, and the research coordinators work with the participants to fill it out. So the original raw name, just like Dan had the NHATS variable name, this is a Survey Gizmo variable name. And then the original raw coding. And so you see for this one, it is kind of like a 0, not true for me rarely, going up to true for me all the time. And then the next column is the SAS variable name. And then whether we kept the coding the same. On this one, we kept the coding 0 to 3. Some of them, as we know, we reverse code, but we wanted to make sure the always not for me or rarely were 0 across all data set. And then we just have the variable type, and then the instruction for the participants, which was a radio dial. And so the participants and the RAs picked one of these. So as opposed to select all that apply or something. And so we have that column. Also, and so this is everything. And then this one has subscale. So I don't know if you can see in the bottom of the Excel, there are tabs. And this one we're looking at is actually, this one, so there's subscales for this. And so there's the overall, and then there's the subscales. And if you click on the last one, Dan, there's a descriptive tab. We also provide this descriptive statistics. Again, trainees using this and bringing this in, and so a sense that they have confidence, or they can double check when they brought in their data, again, are interoperable to whatever software they're using. We have SAS users, R users, SPSS users, Stata users on this team. And so we provide this descriptive statistic as part to get a look at it as they're planning their research questions, but also that they can replicate this when they bring this into their survey. And so this is another example of a code book and how we did it for this study. And we have so many of these because, like I said, we have 5 pages of just scales and questionnaires. And so this has been a great process. Again, try and do it up front and for the long run. So if there's any questions out there or comments, please chime in. All right, so now.
If not, then to move on to Trisha's section on automated codebooks.
Okay, this is going to be a bit on the brief side, but one of the things that I wanted to point out is that you could use this automated code book. There's a Shiny app. I'm in the process of finding out how appropriate that might be through our IT program to be able to use the Shiny app on various data sets. However, it's if you have a publicly available data set, and there is an example that I would post up a little later from the teaching statistics website at ASA, Health Statistics, that you could see what's happening in terms of a code book, and I do have a copy of that. But if you click on the link, this will take you to the Shiny App website. Thank you for doing that, Darren. And you could choose a file from SPSS, Stata, an R file, Excel, CSV. And if you pull in a data set, you could generate a code book fairly easily. Now, the issue is, one of the things is that this data would stay on this site for a day, and we don't want that to be able to happen. And then it's removed. So what you could use is this code book information in R and have it within your own program on your secure computer. So one of the other things that I've noted, and if we could click on the net, just click going forward, you'll see that there are some install packages, and with R, the package name is codebook. There's also form R that could be used. I've also identified two areas. One is the GitHub site in terms of where all of these codes might be held, as well as some additional information, and a tutorial. So the tutorial is another in terms of the code book, and it'll walk you through step by step in the process. If you could click on the GitHub, I'm sorry, is there a question? Okay, thank you. So you'll see in terms of any vignette, this code book is allowing you to go through and work on what's happening in terms of the metadata. It's indicating that there is an add-in for RStudio. If we could go down a little, the generation of the code book. There also, you could see in the section, it's this Form R, which is another online survey framework, as well as the documentation. A point I'd like to make in terms of this is the data set that I use from the teaching statistics, health statistics site is on a smart pill, right? And the smart pill had a data dictionary with it. Fortunately, because the data sets were available in a variety of formats. However, when I read it into SPSS, what ends up happening is it transformed everything into just a string file. So you're not getting the information that you would need, and that can pose a problem on many levels. So it's a good thing in terms of a check, and these automated sites could be used as a check, again, using it on your own computer. And then if you just go down a little, you could see what's happening in the code, and then how this can be cited. Well, the citing in terms of the paper. This is open access paper, so you could take a look at it, click on that link, and you would be able to go through the paper. Has some nice examples, as well as a table that would illustrate some other packages that are available and pros and cons of these features within the packages. Darren, if you could go back to the sites, and it's also listed here and on the slide. If you could go to the next slide, please. As I've also, and click again. So there are some SPSS reports in terms of generating a code book. So you could display a quick version, and that would be with display dictionary. But you could do this in two ways. One, you could do the GUI fashion. So in SPSS, you would go to File, then display the data file information in terms of the dropdown, and then to the working file. Automatically, this will send the syntax to SPSS. You look in the output, and you will get what's looking like a nice data dictionary. So it'll have the information, and then it would follow by the variable names and the variable labels for the particular labels. Another more detailed code book is going to analyze within SPSS down to reports and then code book. Here is the syntax, and there is also just an automatic determination. You could just work in, identify the variables in terms of your code book, ask for some additional information. You could have some statistics with it. We have options in terms of your variable list, and you would have information relative to where your data is stored, recommending what's happening in terms of the file information, the file name, the location, how many cases, and the labeling in terms of your documents. Then based on the different types of documents, so if you have nominal, which is the grouping, gender, race, in terms of this SmartPill data set, height is a scale variable, weight is a scale. So you're seeing nominal, ordinal, and scale level variables, what's available in SPSS. So those are some of the pieces in using codebooks and using syntax, being certain to have a good deal of commenting. So you could easily go back, and it will, in fact, save you time. So, any questions?
Thanks,
Okay,
Trish.
thanks, Trish.
Thank you.
All right, so we've got a few minutes left, and in traditional fashion, we probably planned too much to cover too much ground in one session. But we did want to remind everyone that there are template data management and sharing plans available on the NIH website. Let's see if I'm smart enough to figure out where this is. Okay, so there's an example one here. I'm not going to take a ton of time to go through it right now. But you can see that they've sort of broken it down into kind of different sections and specifically describe kind of what you need in each section. And this particular example, which I, again, just downloaded straight from the NIH website, has examples of what you might write for a secondary data analysis. So that's analysis with existing data, but they also have examples for other types of analyses as well. So this is a really great tool. It's a really great way to help you get started. Another tool that a team member of ours just pointed out to us today, Megan Smith, is this DMP tool. It's data management plan tool. And Drexel is a participating institution with this tool. And this will actually help you automatically, well, not automatically, but it will guide you through the process of writing a data management plan based off of the institution that you're applying to for a grant. So you can select like NIH, and it'll give you some prompts to fill out things for what you need to fill in for an NIH plan, and then it will output a document for you. So it's a pretty cool thing. We haven't had a chance to really explore it yet. But this is just another resource that's available at Drexel that I think maybe a lot of people aren't really aware of.
And one thing I want to know, if for people who don't know, the library,
Mhm.
actually the libraries has a research data management. I don't know if you have that up. And
Yeah.
so our Drexel libraries list some resources, and this is one of the resources listed. So if you haven't gone to check out Drexel libraries, oh, there it is, research data management support. They have some resources there as well.
Mhm. Okay, and then just to get you an idea of, I've lost stuff because we've got so many things we're trying to say. So just to give you an idea of, so again, there's these, again, this is something we touched on last time, but there are these NIH data repositories that you're sort of expected to put data in. You're expected to store your data someplace when you're done with your study. And the NIH has a database of places where you could potentially store that data. And I'll go ahead and click this here just so you can get a look at what it looks like. But I find this to be a little bit overwhelming, personally. There's just hundreds and hundreds and hundreds of different places you can put data here. So this is something where really talk to your colleagues, talk to other people. So people have knowledge on kind of how to best approach this, or even if you want to chime in now, it's something that is definitely going to take some time and consideration on your end when you're preparing this. And just to give you an example of what kind of a more generalist repository might look like, this is the IEEE data port. This is suggested from the NIH. They do have a free repository, but I do want to point out that sometimes these repositories can cost money. So if you want an open access data repository, I think there's a flat fee of about $2,000 that you have to pay. So part of the NIH data management plan is budgeting for this kind of stuff. So again, something to carefully consider when you're putting together your grants. But we did have, again, we're basically out of time, but we did have an outstanding question, which was, does Drexel have an official data repository? And this is a genuine question that we are asking because we're still trying to figure this out. No, they don't.
I mean, the Office of Research did say that we should be and Drexel's not going to be in the business of developing a data repository, and that we should be using the NIH's free repositories.
Okay.
But I don't know, there is supposedly a server that we all have access to store big data if we wanted to, but that's not what a data repository is.
Right. And I wonder, so for some of these, I was looking at some of these repositories, and some of them are like, you can have an institutional subscription to some of them, which would, I think if there was some guidance from the university, it would make it easier for people to identify where they can put their data, especially if we had something from the university that was like, we've already got a subscription to this. But I'd be interested in learning more.
We can wrap up and say the answer is no. There's no official data repository.
Sorry.
That Drexel is having conversations about. Right now, the official word is to go to NIH and use theirs. But there are conversations, and we're hopeful that maybe Drexel will, as Dan saying, maybe subscribe to one of these or somehow more proactively help us in this area.
And the BSC is talking to a lot of different teams. So different people come to us with different ideas. So if you want to kind of just bounce off ideas or ask a question, then feel free to ask us.
All right.
Well, thank you all for joining us today, and we'll see you next time at our next Tuesday topic. Thanks, everybody.
Thanks, everyone.
Thank you.
Bye.